Hello, this is Mr. Fay. Today we're going to review how to use a triple beam balance to find the mass of something. When you first come up to your triple beam balance, you want to take a look at the three arms that you have and make sure that the weights are all the way over to the left. When the weights are all the way over to the left, this little spot right here should be completely zeroed. If not, there is a little knob right underneath the pan of this balance that you can rotate clockwise or counterclockwise, which will help to adjust this in either the up or down direction. Once you've done that, when all your weights are over here, this should be lined up perfectly. If not, you probably want to raise your hand and talk to your teacher to either review that skill or check to make sure that the balance is working properly. Great, what we're going to do is we're going to take a look at what happens when you put an object on a triple beam balance and how do you get it to balance. So I'm going to grab this little cube, we're going to pop it up like this, and when you set it on the pan of the balance, what you're going to find is the balance will drop because we have more weight on this side than the other. When that side drops, this side up here will go up and it will no longer be balanced. You then have to direct your attention to the arms. What we're going to do is we're going to look at the hundredths arm first, which I'm highlighting in red for you. And you'll notice that there's a big old weight on this that we're able to move across the arm. Now, this is kind of cool. You're going to notice there's a little like notch right in here. This can only fit in these little grooved positions at 100, 200, 300, 400, and you simply continue to move these until this side here falls. And when this side here falls, you know you've moved it too far. So if it fell when we moved it to this position right here, we would simply bring it back one and cause this to go back up. So once that's done, this would become the position of the arm. Next, we'll direct our attention to the tens arm, which I'm going to outline in green. This right here is our tens arm. And the tens arm has a weight that's grooved also. You see a little tiny groove right there, and the weight is hanging out right here. What you do is you'll move this from groove to groove or notch to notch until eventually you get to this magical position where it falls again. Once it falls, you back it off one, and that becomes the next position for your tens arm, hanging out right there. Finally, and this one's a little bit different, you're going to look at the ones arm. Now the ones arm does not have notches or grooves. In fact, it's completely free-flowing, and it can exist anywhere on this arm that you have right here that I'm highlighting in blue. So what you need to do is slide it down, slide it down, slide it down, slide it down until you get to a point where it is perfectly balanced. Okay, this one might take a while. So again, this can exist anywhere on this arm. So you might have to keep going back and forth for a little bit until you find that perfect spot where it's going to zero. At this situation, or at this time right here, that is the situation in which the balance will be completely balanced and ready to read. So here's the placement of our hundredths arm. Here's our tens arm. And here is our ones arm. Now, it's hard to read on this diagram, so what I'm going to do is I'm going to advance to another slide, which is going to be a little bit easier to read. It's just a little scan that shows what could be some possible positions for these arms. This one shows the hundredths arm up top, which is actually at 500. And it shows the tens arm, which is at 40. And then it shows the ones arm, which is the free-floating arm. It doesn't have the little groove, so this is hanging out right here just past 5. Now you'll notice it's 5 and 2 little marks, which makes this 5.2. Now in order to read this, it's relatively simple. All you need to do is add the arms that you have. So we've got 500 from the hundredths arm, 40 from the tens arm, and 5.2 from the ones arm. The unit for mass using a triple beam balance is always going to be the gram for the one that we're using here at school. So this becomes your answer, 545.2. And just to recap, the 500 is coming from the hundredths arm, the 40 is coming from the tens arm, and the 5.2 is coming from the ones arm. Hopefully that will help you out and serve as a nice little review for how you use a triple beam balance to find mass.